Hello guys and welcome back to CS with Mr. G. This is our Unit 4 review video where we will go through some typical exam style questions specifically for Unit 4, which is all about software, where we will go through some typical exam questions and look at the mark scheme when it comes to these types of questions. We will go through the marks available for specific questions and I will offer you some hints and tips to remember certain answers and hopefully make this unit as easy as I can to understand and achieve maximum possible marks in this area of the exam. So if you make a start on question 1A, an interrupt is a type of signal that is used in a computer. State the name of the type of software that manages interrupts. There is actually two possible answers in this question. The first one being the operating system itself, so the actual OS as a whole, or if you wanted to be specific, you would say the interrupt handler. So the interrupt handler is the specific piece of software that deals with interrupts in the computer, where in the next question, 1B, we will discuss how the interrupt handler works when it comes to pressing a key on a keyboard. So first and foremost, when the key is pressed, an interrupt is generated. So 1 mark for saying that the interrupt is generated when the key is pressed. The interrupt is then sent to the CPU, where it is then placed in a queue, and the queue will depend on its priority. So if the interrupt has a very high priority, it will go to the front of the queue. Otherwise, it will just go behind the more important priorities that are ahead of it. We then need to mention the ISR, which is short for the interrupt service routine, which checks the queue. So the ISR checks the queue and will stop the CPU. So stops the CPU in the current process in order to service the interrupt, so to make sure that it's dealt with. And there you go, guys. There is 1, 2, 3, 4, 5, 6 possible marks there from a total of 5. And again, this all comes back to interrupts and the interrupt handler. So keywords to get in are the ISR, stopping the CPU to service the interrupt, talking about priority, and of course, just mentioning that the interrupt is generated when a certain event occurs. 1C is another question about interrupts, where we have to mention 2 other examples of hardware interrupts, just like a key press. So a piece of hardware that could cause the CPU to stop running would be something like clicking the mouse or even moving the mouse. You could also mention plugging in a device. For example, if you plug in a USB flash drive, it will pop up with a message saying, what do you want to do with the flash drive? Or sometimes if you plug in an audio wire, it will ask you what type of audio device has been plugged in. So plugging in a device will cause an interrupt. A paper jam, also in a printer, would cause an interrupt, or something else to do with the printer is running out of paper. So just be careful. These are all hardware-based interrupts. So hardware means a piece of equipment that could cause the interrupt to occur. A software-based interrupt would be something that involves a program. So opening a program or trying to find a file. So just try and remember the difference between a software and a hardware interrupt. And question 1D actually talks about the software interrupt. So we can mention a missing file. We could mention a division by 0. This is very common in the paper 2 exam, as this is what we call a run time error and would cause a program to crash. And you could also mention 2 processes trying to access the same location in RAM. So again, these are software interrupts and would cause the CPU to stop what it's doing and for these to be serviced. Question 2, describe the purpose of the operating system. Well, if you think back, the operating system does a lot of jobs. We need to name 3. So first and foremost, it provides a user interface. This is one of the easiest ones that I can remember. So it provides a GUI, or just mention user interface. It also manages the hardware, make sure that all the hardware runs correctly. It also provides a platform to run software. Without an operating system, a computer would be useless. You would not be able to install any programs and particularly not run any software whatsoever. You could also mention any other task that it performs, such as a file manager or memory management or even multitasking, all of which has been discussed in the Unit 4 playlist. Question 3 is to fill in the blanks, and we have to complete the statement about different types of software using the terms from the list. Some of the terms won't be used. You should only use each term once. So something software provides the services that the computer requires. An example is utility software. So there are 2 types of software that we have covered. They are system software and application software. And we should remember the software that provides the services to the computer are classed as system software. So we can tick that one off. Something software is run on the operating system. So that's the other one. That's application. Just think of the word app. So any app that you have on a computer or even a phone, these are run on the operating system. If you've got an iPhone, you have iOS as the operating system. And on top of that, you have all of your apps. And again, app is short for application. If you've got Android, it's the same. If you've got a Windows computer, you'd have Windows OS with all of your programs installed on top. So nice and easy, that will be application. And then something system is run on the firmware. And if we look at these words available, there's only one word that goes with system, and that's typically operating. The operating system is the bottom layer of software. Underneath the operating system, we have firmware, which is basically the hardware, including your BIOS and all your startup instructions, which gives us a clue for the last word, which is run on the hardware. So firmware is related to hardware, and above that is the operating system. Question 4a. A programmer uses a low-level language to write a computer program for a vending machine. Describe what is meant by a low-level language, and this is one of the trickier units within Unit 4. So what I advise to do here is think of the examples of low-level languages, and if we think back, the lowest level language we have is machine code, which is basically binary, or we have assembly language, which is the one that uses that funny word, mnemonics, and mnemonics are the shortened words, things like add, sub, mov for move. Okay, so the really short words are what we call mnemonics, and this was the example of assembly language. So that would get you the 2 marks. Another mark could be closest language that is processed by a computer, and then give 2 reasons why you would choose to write a program in a low-level language instead of a high-level, which again is a tricky question. So why you would want to use a low-level language. And if we think back to the first question, the programmer is writing a program for a vending machine. So that gives me a clue that low-level languages can be used with specific hardware. So can be used with specific hardware. It's not a general computer. We're talking about a vending machine. That's your first mark. You could also say it's quicker to execute. It doesn't need to be translated. So no translation, or less translations, should I say. You don't need a compiler or interpreter. So compiler or interpreter not required, which makes it more memory efficient than a high-level language. Okay, so any of these 4 for your 2 marks as to why you would use a low-level language. A programmer writes a computer program using a high-level language. Tick 1 box to show which statement is correct about writing computer programs using a high-level language. So as we've just said, mnemonics are used in low-level languages, so it's not that one. The computer program is harder to debug. Well, this is false because high-level languages are easier to debug. The computer program is machine independent. This is true, as you are not programming specific hardware. Programs are portable and can be run across multiple types of hardware. Hence why you can have apps on all kinds of different devices, so it's not dependent on the machine. They are what we call portable, which means the last one is false, so the hardware of the computer can be directly manipulated. This goes back to a low-level language, which we've just seen. The programmer uses a compiler to translate the program. Describe how the compiler translates the computer program. Well, first and foremost, it translates from a high-level language, that says high, so it translates from a high-level language into a low-level or machine code, you want to be specific. A compiler translates all the code, so translates whole program before execution, which means it creates an executable file. So this is a very important keyword when it comes to a compiler. So it creates an executable file, which is different to an interpreter, where I'll quickly just mention an interpreter is line by line. So it runs code line by line and will report errors as soon as they are met. This makes it very different to a compiler, as in the next question, we need to describe how the compiler reports errors. And basically it creates what we call an error report. So creates error report, that'll be 1 mark, which contains all the errors in the code that need correction before the program can run. So any 2 of those for your 2 marks. And question 5D. The programmer uses an integrated development environment to create the program. One function of the IDE is that it has a built-in compiler. Give 3 other common functions of an IDE. So hopefully by now you've used an IDE to write some code. And first and foremost, you know an IDE has somewhere to write your code, which is called a code editor. They also have some kind of tool that will be able to check for errors and tell you whereabouts an error might be. And more advanced IDEs have functions such as auto-completion, where they will offer suggestions on how to complete a line of code before you've even started to write it. So auto-completion. Auto-correction is another one. So if you've made a mistake, if you spelled a variable wrong, again, an IDE might offer you advice on that. And also they offer something called pretty print, which makes your code nice and readable, including the use of white space and indentation. Oh, and also color coding words. This is also classed as pretty print, just making it easy to read and easier to understand. Question 6. A user has both system software and application software installed on their computer. Describe the difference between them, giving an example of each in your answer. Well, first and foremost, system software is software that is required by the computer to run. So things like disk cleanup or even antivirus software. You could also mention firewalls, but basically software that keeps your computer running as it should, or you could even say the operating system itself. As we already discussed, this is the fundamental piece of software that you need. So you could mention the operating system itself as system software, clues in the name, system, and application software is software that the user might require to complete a task. And you've got a bunch of application software you could use. You could say a web browser, a word processor, photo editor, basically any piece of application software that you've got on your phone or computer right now would be classed as application software. It's not necessarily needed by the computer, but it is what we use in order to perform our tasks. And finally, question 7, software is installed on a computer to manage files, memory, and multitasking. Again, we've already discussed some of this. This is the operating system's job. The name of this software is the operating system. We've spoke about quite a lot. Give one task that it allows the user to do to manage files. And as we know, there's quite a lot of things you can do with files in an operating system. You can create a file, you can copy a file, you can delete a file, you can move a file, save, sort them, and even open them, which I forgot. But any one of them for the mark. But as we know, the operating system allows us to do all of these when it comes to files. Managing memory is also a job of the OS, and we're talking about RAM or main memory here, not secondary storage. And the OS keeps a track of all memory locations, so what's being stored in the RAM, that's one mark. It will also move data in and out of RAM. It makes sure that processors have enough memory so that they can work properly, and it will also make sure that two processors don't access the same memory location, and it does this by going back to the first point of keeping a track of all the locations and what's being stored in them. And to finish off, which takes us right back to the beginning, the type of signal that is sent to the computer to allow multitasking to occur. This is an interrupt signal, which we mentioned at the beginning. So an interrupt signal is what allows us to multitask. So well done if you followed along, guys. Hopefully you are well equipped to answer the Unit 4 questions in the exam. Next up is Unit 5, which is the internet and the World Wide Web. And I look forward to seeing you there.